Welcome to Brain Vision.
We want to find the magnetic field that's made by two wires. And so we know that the current in these wires must be going in opposite directions, since we're told that this is wires that are carrying current to an appliance and then back away from the appliance. So the net change in charge has to be 0. So one's taking it to, one's going the away. So they both then are going to have the same value of I, which we're told is 2 amps. And then we're told the wires are separated by a distance 2.8 millimeters, so I've called that D. And then it's a distance R from the center of the two wires, which is 10 centimeters. And that's where we want to find what the magnetic field is. So we can just say then our magnetic field is going to be the sum of the magnetic field made by each of these two wires. And I don't think we're actually told that this distance is off to the right. It could be to the left. So really, we're just going to find the magnitude of the magnetic field and not worry about the sign. So we're going to have from wire 1, mu naught I1 over 2 pi R1. And then regardless of whether this point is on the right or the left, these two wires will have magnetic fields of opposite sign. So that's really all that matters here for the magnitude. And so that will then be mu naught I2 over 2 pi R2. So that's just sort of the most general form, but we can simplify that a lot in this situation. So we'll factor out the mu naught over 2 pi, and then I1 is equal to I2 here, and they're both 2 amps. So we'll factor that out as well. And now we're just left with 1 over R1, and then minus 1 over R2. And then R1 and R2, so thinking about this first wire, that one is going to go this total distance. And so we can see that's just R and then plus half of distance D. And then for the second wire, it'll be going just this distance, so R minus half of this distance D, so R minus D over 2. So we're just going to have then 1 over R, and then one side will be plus D over 2, and the other will be R minus D over 2. So the signs here, all this is going to affect is whether we get a positive or a negative value for current. But again, we just care about the magnitude. And so we know our R of 10 centimeters, so we just want to make sure we convert that to meters, as well as converting our 2.8 millimeters into meters. And when we do that and evaluate this, we should get 1.6 times 10 to the minus 6 Teslas. And then we're asked to compare this to Earth's magnetic field. So we just take B from the wires here, divided by B of the Earth, and that will end up being about 0.031. So that means the wires make a magnetic field together at this point that's about 3.1% the value of Earth's field.